night may be long and the dark may be deep, but the answers are there to be found. Whether it's the normal, the abnormal, or the paranormal, you're in the right place. Let's go beyond reality.
It's Tuesday on the West, Wednesday on the East. Many of you are stuck somewhere in between. Welcome to Beyond Reality Radio with me, Jason Hawes, and the always awesome JV Johnson.
You know, it's a good thing you're back with us tonight. It really is. Because this topic requires at least half a brain, and between the two of us
two together,
right?
Do we actually equal half a brain when we're together?
I'm not sure, but
it depends on the topic. I mean, paranormal. Hey, I can talk about that all day long.
Right.
When you start getting to astrophysics, and things, I got like 3 minutes. Maybe I can.
That's the problem.
It's definitely going to be well. But I mean, the topics are so mind blowing. They really are, and it is good to be back. Sorry, everybody. I know I've been missing a few shows lately, but I'm sure most of you have heard. And we have a new show, Steve, Dave, and me. We got a new show coming out in the fall on Travel Channel. It right now, working title is Ghost Nation. And we're really excited about this because it's allowing us to actually get back to our roots, and where we filmed all these cases when we were with Sci-Fi Channel doing Ghost Hunters. But Sci-Fi decided, and they own the network, so they decided that they wanted to air just these big locations. And it got annoying because all those residential cases where we were really involved with the families were sort of being pushed aside. Well, this is allowing us to get really back into the fold of it, really start connecting with the families again and showing those on TV. And I think that's important. So we're really happy about this. And also that Travel Channel had great to deal with since we started dealing with them. And they're one of those companies that are just like, hey, you guys make a great show. You guys do great investigations. Just go out and do what you do. And we'll air it. We're not gonna step on your toes, and I think that's very important. So we're really excited about this. We're looking forward to it, and I know the fans and everybody out there are very supportive. So it should be good.
Yeah, it sounds like it's going to be great. I'm really excited for it. I'm excited for you. Of course, I'm excited for Steve and Tango too, to get back on the road together. It's always obviously as a big fan of Ghost Hunters, I always enjoyed not just the cases and the stories and the investigations, but the camaraderie and the fun that you guys always had when you were investigating.
And that's going to be shown, let alone we're also going to be showing us getting out and just being ourselves, doing in the first few seasons of Ghost Hunters. I thought some of the best stuff was that we did things as a family. We went out, we hung out, we went out and screwed around and did all these things, whether it's walking the streets in New Orleans or getting in goat carts and driving around. We went out and we had fun, and we're going to be also showing that again, because I felt like when Sci-Fi started removing that from the show, even though we were still doing it, it kind of took away from that that whole just the big family mentality of us getting out and doing all these fun things. So we're looking forward to that, and just so everybody knows, the radio show will not go away. It's still going to be here. It's still going to grow, and there'll be times that I'm on the road, and of course JV will be handling that, but also I have a traveling system, so I'll be able to still do the show a lot of times while I'm on the road as well. And the show's just going to continue to grow.
Yeah, no, we love doing this. It's a great way to connect directly with people who are not only interested in the topics that we talk about, but are actually passionate about it.
Well, this is our baby. We built this. We built this from just screwing around online together to a nationally syndicated radio show, and it's extremely important to us. And so this thing is here to stay.
Yeah, and there's another thing I wanted to bring up, and it's kind of a tangent, but it's really important. And now that you're here tonight, Jay, I think it's a good night to talk about it. But of course, we lost a legend in the paranormal community a few nights ago. Lorraine Warren, obviously part of the Ed and Lorraine Warren paranormal investigating team. You know them probably because of the movies that have been out recently based on some of their casework. Well, she passed away. She was, I think, 92.
92 years old.
Yeah, 92 years old. Just an icon in the paranormal community. Sometimes controversial, but I guess everybody in this business can be. So our hearts and prayers go out to everybody in her family. John Zaffis, who's a good friend of ours, Jay, is their nephew. Yeah. And actually, we tried to get him on the show to talk about it, but he's obviously wrapped up in family plans and stuff. So,
and Lorraine, of course, it was one of those things, like you said, controversial and so forth. Every time I talked with her, she was a very nice person. We had different belief systems, but I still respect them for what they did. Ed passed away a few years back. Great guy, very, very intelligent. And whether you respected them or not, you need to at least respect what they were able to do and accomplish in this field, and that they brought awareness to it. They really opened a lot of doors. And without people like them, just like with Art Bell, I mean, we wouldn't be here if it wasn't for somebody like people like Art Bell. I don't think I would be here, or TAPS would be where it was, without Ed and Lorraine Warren and them helping in the field.
Yeah, and I had said on Facebook at one point in talking about Lorraine that their work made our work possible, and that's true. And I sometimes you look at some of the work that becomes discussed in a controversial way, and you have to say, maybe they were so passionate about it. They went after things that maybe they shouldn't have gone after, but it was a passion that drove them. I don't think it was anything malicious. So, again, I applaud their work. I think they were trailblazers in the field, and we'll miss both of them now. Hopefully their legacy will live on.
And they're finally back together, I think, right. And that's important enough. Speaking of things like this, the investigation. Now, back in 2005, we investigated the Crescent Hotel. And I think you remember that out in Eureka Springs, where we caught this weird soldier-like entity on the thermal imaging camera with this number 2 on the chest. Well, you know what they just found at the Crescent Hotel, Jim? A bunch of jars with body parts.
That is so bizarre.
Yes. So, all right. So, of course, season 2 was episode 13. Back in 2005, we investigated. The Crescent Hotel was built in 1886 as a resort for the rich and the famous, but quickly became unmanageable and fell into disrepair. After the place closed in 1934, the Crescent was leased as a summer hotel. In 1937, a guy by the name of Norman G. Baker turned it into a hospital and a health resort. He claimed, I got to be honest, he claimed he had the cure for cancer, and he treated a number of patients, but none, of course, were cured of the disease. He wasn't a doctor. He was a con man, and he did promise cures for tumors and other issues, and he removed body parts from these patients and expected high pay for his tactics. Many, and I mean many people died in his care. We went through some of the files when we were there, and it was just horrendous to read some of these things. Well, strangely, these jars that were the property of Norman Baker have been found, and they have a bunch of body parts and in them, and it just shows you the morbid side of what truly went on there, and also it probably helps solidify why there's paranormal activity at that place.
Well, the paranormal activity itself stands for itself. What was going on there is obviously just disgusting in many ways. Did they say where these things were hidden the whole time?
They haven't gotten into too much detail, but that place is monstrous. I mean, and it's so incredible when you're there. Our first night there, we didn't get in until like 4 a.m, and of course we had to be up for the next so many nights. So we sat up as late as we could, and finally crashed. But it was like 6 a.m. in the morning. The building was struck by lightning. I think you remember all this, JB.
Sure, yeah.
And caught on fire. Well, we were all asleep, but it blew out the electrical, it blew out the fire alarms, the phone lines, and everything else. So poor guy had to walk from door to door knocking, telling us the building was on fire. And but I mean, the place is just so incredible. If you see it, you're just mind blown on how it is and where it is. It's just an amazing place. If anybody ever gets a chance, check it out. But it has a really morbid history. And just the fact that they were able to find these bottles that had body parts in them.
Yeah, they're probably like formaldehyde things. You see them in whatever.
I mean, this guy would remove people's skull caps, take crushed walnuts and mineral oil and put it on their brain and then put their skull caps back on. So these people were dying morbid, painful deaths. And it's just horrendous to read some of those reports or to see some of the things he did.
Yeah.
But now, like I said, to be able to back up a lot of that with these new jars, I mean, and this guy got away with it, Jim. He never really got charged, sent to jail or anything. It was insane.
Yeah, there was a time where people were more apt to get away with things like that. They could claim basically anything. You know, the whole Dr. McGillicuddy's elixir in a jar cures everything. Go around and sell it for $2 a bottle, whatever. That stuff was pretty well common for a long time.
What, snake oil?
Snake oil salesman, exactly. But we're not going to be talking about that tonight, actually. We're going to be talking about astrophysics with astrophysicist Brian Keating.
Which has nothing to do with what we were just talking about.
No, nothing. But we are going to answer some very, very, or at least try to answer some very, very important questions. Like, does it get any more important than how did the universe begin and evolve? I mean, that's kind of like the question.
Well, technically, he's going to answer these questions.
Right.
We're just going to ask them.
We're going to pretend we understand.
Because we have no idea. We have no idea how
we're going to pretend we understand what he's talking about.
Yes, because the whole thing with the universe, it makes no sense to me. It doesn't add up.
He is the author of a book called Losing the Nobel Prize, a story of cosmology, ambition, and the perils of science's highest honor. So that'll come up in just a few minutes. Tomorrow, we've got Sabrina Scott joining us. Sabrina's a witch, an artist, and a writer. She'll be talking about what it's like to be a practicing witch who has a degree in environmental studies, which I think is just a very fascinating combination. She's also pursuing a PhD.
And then Thursday, we've got Bill Phillips, author of Signs from the Other Side. So we're going to be talking with him. So that's going to be a great show. If you haven't yet, make sure you head over to facebook.com/beyondrealityradio. Like that Facebook page for us. Then head to beyondrealityradio.com, where you can find all the stations we're on across the country. You can also download the free smartphone apps, which allow you to listen live, catch past shows, join the online chat, and more. Or any night we're live, just feel free to click the Listen Live button or the Listen Live and Chat button right there on the website, and you can listen to the show while browsing the web. If you download the show from iTunes or anywhere else, just take 2 seconds and rate it for us. It helps push the show forward, makes it easier to find, and it greatly helps us out, and we greatly appreciate that.
We do. All right, let's get ready to take a break and bring Brian Keating into the program so we can start talking about astrophysics.
Sounds good. You're listening to Jason and JV Beyond Reality Radio. We'll be back after this.
Scaricon New England, the fan convention for all things pop culture, horror, and paranormal, is almost here. June 7th through the 9th at the Sheridan Hotel and Conference Center, Framingham, Massachusetts. Scaricon brings an amazing group of celebrities, including Cassandra Peterson. You know her as Elvira, Mistress of the Dark.
Elvira.
Heather Langenkamp, Amanda Wiss, and Lisa Wilcox from the Nightmare on Elm Street films. Plus, a 40th anniversary cast reunion and screening of the cult classic Phantasm. And many more. Scaricon also features panel discussions, film screenings, great vendors, and parties. It's a weekend of fun from start to finish. For more information, visit Scaricon.com or check us out on Facebook. Use the promo code BRR at checkout to save 25% on your admission. That's Scaricon.com. Scaricon.com. Scaricon New England is being held June 7th through the 9th in Framingham, Massachusetts.
Visit the website today. Use promo code BRR with your ticket purchase to save 25% on admission. Welcome back to the show. It's Beyond Reality Radio. We'll be taking your phone calls later in the program at 844-687-7669. Our guest tonight, Brian Keating. He's an astrophysicist. His website is his name, briankeating.com. And we're going to be talking about his work and his book called Losing the Nobel Prize, a story of cosmology, ambition, and the perils of science's highest honor. Brian, welcome to Beyond Reality Radio. Pleasure to have you here.
Thanks. Great to be here with you guys.
Oh, thanks so much for coming on.
So let's start by learning a little bit more about you. Your credentials are almost beyond what I can even understand, given the topic that we're going to be talking about.
Let's just call it intimidating.
It is intimidating. Let's talk a little bit about you. Tell us about yourself.
Yeah, well, I do have an advanced degree, a PhD, but I'm not the kind of doctor that helps people. I always put that out. I don't prescribe medicine except on rare occasions, and I still need to sing the alphabet song to know what comes after the letter Q. So please don't think of my intellect as too far beyond your capacity to understand. But I do study the origin and the evolution of the universe using tools and technologies, primarily telescopes and detectors, that see the invisible, not the paranormal necessarily, but I do see invisible signals from the very earliest reaches and farthest distances in the entire cosmos.
And when we talk about observing the invisible, are you talking about radio waves of some kind? Are you talking about some other kind of just non-light energy?
Yeah, exactly. It's primarily radio waves. In this case, it's called the cosmic microwave background radiation. So it's a form of microwave energy, which is a shorter version of radio wavelength light. And sometimes we call it radiation, but it's essentially radio waves of slightly shorter wavelength, as I said. And in our case, we're not only trying to see these photons, this radiation from the early universe, about 400,000 years after the Big Bang, but we're actually trying to visualize and use that light to visualize what came before the formation of the elements, for example, before the first microsecond in the universe, before the first nanosecond in the universe. And to do that, we need to make use of another type of radiation, which is not electromagnetic in origin. It's not a radio wave or an infrared light wave. It's actually called a gravitational wave, and we can talk about that if you like as well.
Well, and you're saying that you're looking for what actually happened before. Well, you're trying to figure out what happened before the Big Bang, what led up to that.
Potentially, yeah. So, as you know, light travels at the fastest possible speed known to exist, which is conventionally 186,000 miles per second, fast enough to reach the moon a 250,000 miles away in about a second and a half. But nevertheless, as fast as that is, it's not infinity. It's not as fast as traveling instantaneously. And so we're always faced with this conundrum as we look out on the universe, even with our eyes. You're not seeing the light from the moon, as you could see it right now from the East Coast, or even from the West Coast right now. You're not seeing the moon as it was now instantaneously. As I said, you're seeing it a second and a half old. Now, that's not a big deal. When you're talking about the moon, a second and a half is not a big deal. But when you're looking at the universe, you're looking at galaxies, you may be looking at things whose light left that source 1 billion years ago, or in the case of what I say, this cosmic microwave background radiation, 13.8 billion years ago. And that's the time machine-like aspect of astronomy using these types of telescopes, and that is unique amongst all the sciences.
We have just about a minute before we have to take our break here, but this is an idea that has always fascinated me. When we look out into our night sky and we see, the millions, if not billions, of stars that are visible to us on a very, very clear night, we are seeing light from stars that may not exist in some cases because it's taken that light so long to travel to us. Is that right?
Absolutely correct. Yeah, sometimes you may be looking at a corpse from beyond the grave, and you would have no way of knowing, and they would have no way of knowing if there's life in those other solar systems, and perhaps we can get into that after the break.
Yeah.
But that's exactly right.
Yeah.
And in fact, we're trying to extend the ability to look back in time beyond the very limits of our own observable universe for the very first time in human history.
All right, so that short sentence there has just created so many questions in my mind that we've got to get through this break because we got to start asking them.
Yes, so we're going to take a quick break. Our guest is Brian Keating, and you're listening to Jason and JV Beyond Reality Radio. We'll be back after this.
Did you know that online retailers like Amazon have constant deals that can save you money on the things you buy every day? It's no joke. Save 40%, 50%, even 80% on great products, and all you have to do is know about them. Noodle Shark is the way to be alerted when something good is coming your way. Noodle Shark is the social media page that lists great deals that not only save you money, but give you the deals before anyone else has them. All you have to do is find Noodle Shark on Facebook. Search it as The Noodle Shark. That's The Noodle Shark, because you deserve to save too. Become a shark and save. Yeah, we're all trying to come together tonight here with this idea that light traveling at the speed of light, of course, still takes billions of years to travel across some distances. And when you're viewing that light, you're looking at basically something that happened billions of years ago. And bringing back to this idea, Brian, we talk about time travel, and I know Einstein had some theories about this, and believe me, I don't even begin to scratch the surface of understanding all of this stuff. But if I were to simplify these ideas, are those types of time travel concepts based on outrunning the light so that you can see the past?
Not exactly. It's more based on the fact that light travels at this finite speed, although it's quite brisk. It still takes a finite amount of time for light leaving an object to reach us. And you may remember, although you're probably too young, when astronauts landed on the moon, there was a great pause as they landed and communicated, the Eagle has landed, and then they would find out a second and a half later. And that's because all waves of radiation that we know about travel slower than or at the speed of light. And they only can travel at the speed of light if the source of the wave has zero mass. So photons have zero mass. They're the particles that carry light energy. They're the named by Einstein himself. And a consequence of Einstein's theory is that nothing can travel faster than the speed of light and convey information. It may be possible to convey, if you two of you guys go off on a trip and you both, you have a pair of red socks, and then somehow your socks get mixed up red and white, and you open your suitcase and find you've got one red and one white, instantaneously that, JV's got a white and a red also. But there's no way you can use that to signal information, if that makes sense. So nothing travels faster than the speed of light that carries information. What we're trying to do is see an earlier form of light that could have been created at the Big Bang's first trillionth of a second or even earlier, and that may be a harbinger of what happened before the Big Bang, as one of you two asked me earlier on in the show.
Let's set some foundational information here. What are the current theories about the Big Bang? How long ago did this occur?
So we know with great accuracy that our observable universe came into existence 13,799,000,000 years ago, which we know with a precision of less than about 1%. That's equivalent to guessing somebody's age to come a couple of months, just at looking at them and knowing nothing else about them. So it's quite precise, and yet we physicists aren't content with knowing exactly how old the universe is or even what it's made of, because in order to fully say we understand something, we need to know what happened to create the conditions for that particular system. So if I look at, say, a ball rolling down an inclined plane to, perhaps bring back nightmares of high school physics, you have to know what height the ball started at in order to know what speed it's going to get to at a given point later on in its rolling. Similarly, physicists would like to know what happened at the very beginning. What energy state did the universe get created with? Did it begin its existence with? So although we know with great precision when the universe came into existence, we don't know what happened before that event.
Well, and that's actually something the wife and I have talked about many times, because I have a hard time with every science, of course, kills God and vice versa. But my problem is everything has a beginning. So if everything has a beginning, how can everything have a beginning, but everything does have a beginning?
Yeah, so actually that question is as old as time. It's as old as the contemplation that scientists had even before there was such a thing as science. This goes back to the ancient Greeks, presumably even beyond that, when man first started to wonder, where did it all come from? And for millions of years, probably the answer was unknown until Aristotle and others began to speculate that the universe had perhaps existed forever. And actually, they were quite sure of that. The existence was eternal until about the time of Isaac Newton, actually, who was a deeply devout religious Christian, as you may know. And he, although he dabbled in the paranormal, as I'm sure you guys know as well. And this great scientist began to worry about the consequences of his theory of gravity, which said that everything that exists that has mass attracts everything else via the so-called law of universal gravitation. Universal means everything pulls on everything else. And in his conception, he couldn't understand how the universe could be static for all time with the knowledge that the universe contained matter, right? So it was basically a paradox, how the universe could remain static, as everybody believed, from Aristotle up until Einstein, actually. And that viewpoint really wasn't overthrown until Hubble and others saw evidence that the universe is not static, and it was definitive. The universe is far, far from static. It's expanding at incredible speeds, faster the farther you get away from a given point in the universe. And that observation by Hubble, of the famous Hubble telescope name, that observation was inescapable proof that the universe was not static, and in fact was smaller in the past, and perhaps at the infinite past, if you could go back, in time to the very beginning, rather, you would find the universe began with a Big Bang, a singularity, a bursting forth with unimaginable speed, velocity, and power. And yet, we don't know for sure if our universe was the first such entity, the first such venue in which this great explosive creation took place.
Well,
we
and
now
I think,
have a controversy as to whether or not there was a universe that existed before ours. Yeah, go ahead.
No, and that's the problem, because we can't say if we go back to the beginning, because scientifically speaking, there can't technically be a beginning if there's a beginning of everything.
Well, so there are notions that posit that the universe in which we live is actually a tiny infinitesimal speck within what's called the multiverse. So when we were kids, the universe was everything there was. And actually, that has been true for a long time, that people have really spoke of the universe as everything, the sum total of everything that exists. But lately, since, say, the 1980s, a new paradigm started to develop, and it's intimately related to the research that I do, which is called the multiverse. And the multiverse has a whole host of mind-bending consequences to it, not the least of which is that there could be a very large number of alternate universes, parallel in a sense, either in space or in time or both. In some of those universes, given enough space, in the multiverse, I'm the one with the hit radio show, and you guys are the astrophysicists, so you can't rule that out.
Well, no, and that actually comes down to the whole thing of, if we're getting into multiverse, I mean, anytime you sit there and imagine, to the point where if you sit there and imagine something, that imagination takes on a life of its own and actually branches off and creates, the what ifs. So, and that's just never ending.
That's right. And the Everett kind of many worlds interpretation of quantum mechanics, that is another name. Many worlds, if you like, is a synonym for the multiverse. Many verses, many universes.
Because of course, anytime you actually think of something and put the power into thinking about the possibility of, now you've created that branch off, which takes on a life of its own, and it keeps running and growing and expanding, and it just never stops.
Yeah, of course, as a scientist, what we would like to do is to test that empirically. So to use the scientific method of observation, hypothesis, testing, conjecture, and then refinement, and become scientific about that conjecture. And so there are very, very few ways to test things in astronomy, in biology. I have a lot of friends that are biologists, and when they want to test out, what happens if you mutate a particular gene in a frog, there's millions of frogs they can try it on. Don't tell PETA, but they'll try it out and they'll see what happens, right? But there's only, one observable universe as far as we know. There may be other unobservable universes. So how do you test a hypothesis which is intrinsically not only, perhaps singular in that you can only have a sample size of one, which would lead to, very large degree of speculation taken on almost religious faith. I've done a video for Prager University, which is another kind of radio station here. And that video is called, What's a Bigger Leap of Faith, God or the Multiverse? And it's not to really take a position theologically or not. I can entertain both atheistic or agnosticism and theism. But it's really to show that at a certain point, you do have to take things on faith until you have scientific evidence in the form of experimental data. And that's what my projects and the subject of my book is really concerned with. How can we come up with the ideas that can test whether or not we live in a multiverse or not? To me, it's the most exciting question in all of science.
All right, we're going to take a break right now. We're going to come back and continue this conversation with Brian Keating. He's an astrophysicist. Again, his website is briankeating.com. His book is called Losing the Nobel Prize, and we will be taking your phone calls later in the program at 844-687-7669. I want to go back to the Big Bang theory with you, Brian, and I asked you, how long ago it was. You gave me a number that approached 14 billion years ago. Of course, we're talking about Earth years. But give us the nutshell version, and maybe that's a pun that I didn't intend to make. But give us the nutshell version of what this is, because what I understand is that there was a very densely packed small particle that just exploded. Is that what the Big Bang Theory talks about?
Well, we don't really know. In fact, it was mocked early on. The term Big Bang is actually a pejorative. This is a late-night show, so I'm sure I can say it. the Big Bang is really a euphemism for a certain type of sensual pleasure, shall we say, in England, and it was coined by Fred Hoyle, who is a great derisive kind of character, in that he meant it to mock the theory, in that it posited everything came from nothing, and it seemed so fanciful. And what's so interesting to me, and he was a big proponent of what's called the steady state, which to many people seems much more natural, that it has always been, always will be the way it is now. But it was found to be untenable when confronted with evidence that the universe is changeable and malleable and seems to be dynamic and not static. So he confronted this by changing his theory and adding some epicycles to it, and it became known as the quasi-steady state theory. And that eventually went to the ash heap of scientific history. But what so tickles me is that nowadays there's a modern incarnation of that very type of a model that posits there is no beginning to the universe. Instead, there's an unending cycles of time that have stretched from infinity in the past and will stretch to infinity perhaps in the future. And these are called cyclic cosmological models. And some of these have been proposed by none other than Sir Roger Penrose, who is arguably one of the greatest living physicists of our age.
As we explore these ideas, and when we get into our second hour, we're going to get into more detail about your work and the things that you have been able to determine from that work, plus the book. But as we talk in more generalities here about the Big Bang Theory, what is the percentage of certainty that we have that this was actually the what we understand as the beginning of the universe?
So our universe, when we talk about the universe, we're usually talking about our observable universe. So that is the entire sphere of space-time from which we could just now be receiving information, light or waves of gravity or neutrinos coming from distances that we call our horizon. So just like the horizon on the ocean is the farthest that you can get, see something, this is basically the analog of that for the entire universe. So that is quite certain that we know, very much about everything that's happened on, to a physicist. I don't know, you can't predict the weather, every single particle's properties throughout history in the cosmos. But nevertheless, we know the gross details of the laws of physics from about the first 3 minutes of the universe's history on till today, 13.79 billion years later.
I mean, these numbers just the numbers themselves are hard to comprehend. When we talk about the distances, when we talk about the time involved, and the fact that we can actually measure these things, that's almost hard in itself to comprehend.
Yeah, that's what's so pleasant about being a scientist at this time in our in humanity's history. For the last hundreds of years, when people had a conjecture that the universe was finite, say, in age, they couldn't prove it. There just were no tools, no technologies, no experiments at their disposal. And now, not only do we have tools, technologies, et cetera, that can tell us, information about the properties, composition of the universe, we may be able to answer questions about what happened before our universe even came into existence. It's just a phenomenal, exciting time to be alive.
We've got about 3 minutes here before we have to go to break, and I'm going to open up a discussion that may or may not fill that time. It may mean we have to spill it into the next hour. I'm not sure, but I want to ask you about the idea of a divine hand in all of this. Does any of the science that you see or have explored point one way or another when it comes to that concept?
Yeah, usually people preface that question with, I have a simple question for you. There's nothing simple about it, but you've given me an entire, 2 minutes and 10 seconds to answer. So I can't avoid it. I will say that to me, as a scientist, there's two great mysteries. The mystery of how the universe came to be and how we came to exist within the universe. Those are the two questions. And by we, I mean conscious technological life that can comprehend the existence of itself and of the universe. So those two questions are both predicated on origin stories, that they have origination, to them. And in religious traditions, inexplicable kinds of questions had answers that would terminate with a divine being, an entity, a God, a benevolent God, a personal God, a supernatural God outside of science. And so I believe that those two realms are not necessarily in conflict, in that they are both great mysteries and great puzzles and great pleasures to contemplate. But to say that we have knowledge, for sure that there is no God, or that we know for sure that perhaps there is a God, we know it, there's proof, and the scientific world that will never hold up. And I don't think if God does exist, I don't think that he would want us to take for granted his existence, because then everybody would believe, right? I mean, if you could scientifically God exists, then, what would be the sort of, why would there be atheists, right?
Yeah.
Why would there be people that don't believe? Well, that's not a proof.
Right.
But I do find it intriguing to contemplate.
We're in the middle of a conversation here that makes both of us scratch our heads. And like we said earlier in the program, we were hoping that by coming together tonight, Jay, you and I could at least present half a brain into this conversation. So far, we've gotten a lot of great information, but it's created more questions for me than answers, which I think is the nature of this discussion. I think that's just what this does, because there are no definitive answers, or at least not many.
No, there's not, because every answer, every question has an answer, but every question had a question that led into it. So, yeah, it's just, we could be here forever trying to figure this one out.
And we'll be bringing our guest, Brian Keating, right back into the show in a moment. I'll remind you, tomorrow night we've got Sabrina Scott with us. Sabrina is a witch, an artist, and a writer, and she'll be talking about what it's like to be a practicing witch who has a degree in environmental studies, and she's pursuing a PhD. And there's not a tremendous stretch there. I've always considered those who identify as being a witch as being kind of in tune with nature and the environment and the planet. They often talk about the natural elements and Mother Earth as a source of their power. So it's not that far of a stretch for me.
No, and with the name Sabrina, there was really only one field you could go into.
Right, exactly.
So let's be honest. But then Thursday, we've got Bill Phillips, author of Signs from the Other Side. So make sure you tune in. That's going to be a great one. And every Friday, of course, is a Beyond Reality, Best of Beyond Reality Radio. If you haven't yet, head over to Facebook.com/Beyond Reality Radio, like that Facebook page for us. Then head to BeyondRealityRadio.com, where you can find all the stations we are on across the country. You can also download the free smartphone apps, which allow you to listen live, catch past shows, join the online chat, and more. Any night we're live, just click the Listen Live button. You can listen right there from the website while checking out the rest of the web. If you download the show from iTunes or anywhere else, which we know many of you do because the show is downloaded tens of thousands of times a day, and we greatly appreciate that. Just take a couple seconds of your time and rate the show for us, because it helps push it forward and makes it easier to find and really helps us out greatly.
Brian Keating is our guest. His website is his name, briankeating.com, and his book is called Losing the Nobel Prize, a story of cosmology, ambition, and the perils of science's highest honor. Brian, let's talk about the book a little bit. Okay, the title is pretty interesting in itself. What's this book about?
So the book is, I always joke, the book was going to be called Killing Nobel, but Bill O'Reilly has that trademark to that series. So the book is about the perils of pursuing a gilded fame, whether it's an idol in my field, which is the Nobel Prize, or an acting, which is an Oscar, or a Grammy and music. There are all sorts of real modern-day idols that we hold up to and aspire to win, and these have beneficial consequences, but more often than not, they can have really negative consequences on both the aspirants, those who are trying to win these accolades, and also for the fields of endeavor in which they carry out. And for science, there's no higher accolade than the Nobel Prize. And I came to encounter the Nobel Prize on several occasions. The first was really through the invention of an experiment called BICEP, which is chronicled in this book that I've written. And the pursuit of the Nobel Prize played no small part in my desire to create an experiment that could potentially take us back to the very beginning of time and maybe a whisker before. I always say the most interesting question to me is, what happened on the Tuesday before the Big Bang? That would be kind of cool to know about. And if I had been successful, it was clear in my mind, at least, that I would win a Nobel Prize. And that meant a lot to me because I had a lot to prove in my case, to my father, who was a great scientist, but he was a little bit stingy with the accolades and so forth himself. And I wanted to sort of outdo him. I'm a little ashamed to admit, but that was the case, and I knew I could do so by winning a Nobel Prize. And then when we finally did announce the discovery of the earliest possible signs of the Big Bang, and perhaps information on what happened beforehand, on that very day, 5 years ago, St. Patrick's Day, the universe of cosmologists erupted in applause, and no less than the greatest celebrities of science called it not only Nobel-worthy, but perhaps the greatest discovery in human history up until that point.
Wow!
So that was amazing. But then, of course, it's called losing the Nobel Prize. So it's really the story of how we came to come upon not a blunder or not a mistake necessarily, but we ended up having to recant the discovery. And I always say, you see these great discoveries made in science quite often, but a lot of them are eventually retracted or many of them can be subject to further scrutiny, and upon such scrutiny don't always hold up. And so what happens to the scientists in those cases is sort of a subject of what I wanted to display for the world, and how do you bounce back from potential humiliation with humility and move forward in your career. And it doesn't only apply to Nobel aspirants. It applies to those of us who, maybe tried to win a Webby Award or a high school class president. How do you deal, because most of us don't win the golden ring that we're aspiring to. There's just too few, prizes, there's too few people that can actually achieve that. So how do you handle that? And how do you survive and thrive after such a potentially humiliating failure?
You've made statements like believing that the Nobel Prize actually may hamper scientific progress because of the rush to win a prize versus maybe taking the prudent steps that science dictates. Do you believe that fully, or is that something that you offer as a possibility?
Well, I certainly have come to view it with much more skepticism than I did previously. That is the Nobel Prize. I mean, just last week, or 2 weeks ago now, there's a huge announcement. You probably heard about it. The discovery of the event horizon of a black hole. First time in human history we witnessed this. And we saw the exact same kinds of phenomena play out, where there were certain people championed as the leaders. There was a backlash. There was announcements on every newspaper, and so forth. And, I hope that they, didn't make sort of the misinterpretations that we did, and I hope that the claim stands up. But we really have no idea until it's confirmed by another group, and that may not happen for a long time. But nevertheless, people held up, the immediate call for Nobel Prizes for this group. You may have heard about it. And that, to me, is a big negative. It puts, people think that Nobel Prize is this thing that God made, and he gives it out, to the people that most deserve it, and he never makes a mistake. Well, actually, unless you think that 300 white guys in Sweden are God, that's who gives it out. And I was asked to nominate the winners of the Nobel Prize the year after I lost it, arguably, in 2016, and I came to see that they had really distorted quite terribly the specifications that Alfred Nobel put in his will, the most famous will in human history, and they had distorted it significantly from his intentions. And I wanted to kind of chronicle what effect that was having, not only on science itself, but on scientists, especially young people, and those are the lifeblood of science.
But I'm sure you're not saying that it's a disservice to honor people who make great strides or who bring things to the scientific community that haven't been explored or found before, right?
Well, I'm saying that the Nobel Prize borders on the Oscars. So, to the extent that you feel the Oscars is good for film, like, I'm not saying that you shouldn't. I have no problem with the winners of this prize. They can't select themselves. That's like one stipulation that they told me when I made the nomination. They said you cannot nominate yourself. But actually, the distortions that take place, the holding out in the public eye that only 3 people at most can be responsible for a scientific discovery, and that the kind of the broad panorama of how science is actually done is completely overlooked in our desire to have champions. And that's what irks me the most about the Nobel Prize, is that it sets up this false narrative that science is done typically by, white men acting in isolation who are struck by genius. And that is absolutely not the way science is done. It may have never been done that way, but it makes for kind of the hero's journey narrative that so many people are drawn to.
Brian, before we went to break, I mentioned BICEP. Tell us what that is. I know that was your experiment, your project, and it's an important one. Tell us about it.
Yeah, so BICEP is one of these time machines that operate using microwave vision, that they use lenses that bend light in the form of microwaves onto not your retinas as an ordinary, cheap telescope, spyglass type telescope you might have used before would operate, but onto very sensitive detectors made of an exotic material called a superconductor. And superconductors are the most sensitive detectors of their kind in that they can detect, equivalent power to a billionth of a watt light bulb, in 1 second of time. It's just phenomenal how sensitive these detectors are, and that's really what's been the revolution in quantitative understanding of the cosmos in my field. And so we strung together 512 of these detectors at the focus of these optical microwave lenses at the South Pole, Antarctica, because the signal we're looking for is heat. And just like you wouldn't build an optical telescope and put the Hubble telescope in the middle of the glitzy Las Vegas Strip, for us, we wanted to put the telescope somewhere very cold and dark. And for us, there was no better place than to put it at the South Pole, Antarctica. It offered us a potential unobstructed view of the Big Bang from our perch at the bottom of the planet. The South Pole is located on 9,000 feet of ice frozen over millennia that have made it this perch that we can place a telescope and observe for years, in our case, on end, with only a tiny bit of break in between each season. And for half of those, each of those years that we observed with BICEP and its later successors, BICEP 2 and BICEP 3, we were in almost complete darkness. Once the sun sets there, which it does in March 21st every year, and then it won't rise again for another 6 months, meaning that if you are hired to work, an overnight shift at the South Pole, you're going to be there for 6 months now.
And you've talked about the results you've gotten from these experiments and this project, but explain again what the implications of that information are.
So what we were looking for was not only the light that is really the leftover heat from the Big Bang's fiery cauldron that synthesized the first few elements on the periodic table. So if you're a chemist, you're celebrating the 150th anniversary of Mendelev's creation of the periodic table of the elements. And but if you're an astronomer, the only elements you really care about, or cosmologists rather, you only care about hydrogen and helium. Because basically, with just those 2 ingredients, you can make the rest of all the elements on the periodic table using thermonuclear ovens called stars. And eventually those stars explode and they repopulate the galaxy and even the universe with other metals and all sorts of other interesting molecules. And eventually those molecules can be similar to the molecules that make up life. And so, but the very first building blocks, the initial building blocks of matter and life, if you will, came during the first few minutes after the formation of our observable universe, the Big Bang. And those 2 elements, hydrogen and helium, when you fuse two hydrogen nuclei to make a helium nucleus, along with a couple of other players called neutrons, you give off vast amounts of heat. And that heat energy coursed throughout the universe for 13 billion years, and eventually as the universe cooled, it was due to its expansion. As things expand, they get colder. And this happened with the universe. So it cooled from millions of degrees above absolute zero to just 3 degrees above absolute zero, 450 degrees below 0 Fahrenheit. And that's the temperature of the light we're trying to detect in hopes to look for the pattern of what's called B-mode polarization. I won't get into it, but if B-mode polarization existed and we detected it, we claimed we detected it, it was basically seen as proof that the multiverse, this incredible hypothesis that suggests that we are one of an infinite number of universes. We had seemed to prove that back in 2014.
Wow.
Just bring up this because there are these theories out there that, and I'm sure you've heard of them, that if we were ever to understand where everything started or where everything came from, that would pretty much just totally abolish everything that's here today. Now, do you believe in that as well? I mean, if we understood everything about where we came from and everything else, it would just eradicate everything that's ever been?
No, absolutely not.
But you do know that theory that I'm talking about that certain scientists have brought up.
I don't. I think that's an intrinsically non-scientific claim, right? Because it's basically saying that you can incrementally improve your knowledge about the universe, and then all of a sudden you make some transition in which the behavior of the universe somehow conspires to eliminate any further progress in its own knowledge. Now, I will say that the laws of nature that we know about, in other words, the known unknowns about nature, to use Donald Rumsfeld's famous characterization, that is so mysterious. The things we don't know about a universe fills not only my book, but hundreds of books, and there's so many mysteries about the essence of matter, the origin of life, the origin of consciousness. I'm only, quote unquote, trying to address the origin of the universe. But there are many, many other fascinating, equally fascinating, perhaps, topics that one could want to understand. So not only do I think that question is not a scientific reply to the notion of what science is, which is to incrementally improve upon our understanding of knowledge, it actually is a gross underestimation of how difficult the task at hand really is.
Brian, we've got one segment left with you here, and we, in promoting this particular discussion, we talked about some major questions that we're going to ask and get some answers to, at least start to get some answers to. We've talked about a lot of this already, but I kind of want to boil it down to these questions and get some what I would hope would be kind of brief answers to each of them, so we can at least get a sense of what we're talking about here. So the first one that we were going to address tonight was, how did the universe begin? I know you've kind of addressed it, but give us the nutshell version.
So again, when we talk about the universe, we're talking about our observable universe. It's almost a tautology, right? I mean, we're only able to observe what we can observe, and we don't yet have knowledge about potentially other universes. So there is a notion that our universe emerged from the previous ashes of a collapsing universe on the other side, if you will, one that existed perhaps billions or trillions of years before ours. And that universe could have itself been a cycle extending back perhaps billions or trillions of years, or it might not have. It might have been just one precedent universe to ours. Or our universe could emerge simply from the quantum fluctuations of what's called the vacuum, and this is a big subject, but it essentially boils down to the existence of a very particular type of phenomenon called a quantum field, in this case called the inflaton, which when it has its certain kinds of fluctuations that are endemic to all quantum fields, can produce, if you will, non-violations of energy and matter creation that would lead to, in some scenarios that are very popular in cosmology, the fluctuation could lead to the properties of our observable universe with features that are just right for us to later on inhabit. But many people find that kind of Goldilocks paradigm unpalatable, and so they too work on alternative theories that avoid what's called this fine-tuning problem. So it's safe to say that the controversy is as healthy and rich as it ever has been over the past 2,000 years. We simply don't know exactly from what our universe emerged from. What we do know with great precision is what our universe is made of, how old it is, how fast it's expanding, its dynamics, its composition, as I said, and perhaps we know what will happen in the deep future. The universe might eventually rip apart or suffer from infinite dilution. And neither one of these should trouble your listeners because they won't happen for perhaps 1 trillion years or so. So keep paying your taxes out there.
So that leads us into the next question, which again, you've kind of circled around a little bit there. But how did life begin?
Yeah, so these are the three great mysteries. How did the universe begin from a non-universe, perhaps? How did life begin from non-life, right? I said the universe, our observable universe, began with just hydrogen and helium. How does that come to be, a thinking, creative civilization that can produce a radio station, beamed at the speed of light like yours?
Right.
So that's a great mystery. We have notions. In fact, here at UC San Diego, where I teach, some of the early experiments were carried out by one of the four founders of the university named Harold Urey in the 1950s and 60s with his graduate student Stanley Miller. And they replicated conditions thought to be prevalent in the early Earth's atmosphere, and then they charged it with bolts of lightning represented by electromagnetic discharges and petri dishes and test tubes, and got a type of primordial goo that had some of the necessary building blocks for life. It was later shown that those experiments had some flaws, and we actually don't understand. If you go to Wikipedia, which is not a scientific source, but it is a good compendium of knowledge, and it says the theory of what's called abiogenesis, life from non-life. The theory is generally held to be correct, that life can originate from non-life, although the mechanism by which it happens is not understood. So it's kind of ominous, right, that we believe something happened, but we're almost taking enough faith in some sense. And then I always say the third question that goes along with this third Big Bang, if you will, the actual Big Bang of our universe creation, the Big Bang that made life come from non-life, and then the Big Bang that made consciousness come from non-consciousness. Because even if you could get these amino acids to form in primordial sludge to turn into, bacteria, and bacteria to Bach, et cetera, the composer, you still have to figure out how did consciousness emerge. Consciousness, the genesis of that is a great mystery, and it's another fun puzzle to study.
And do you think that that's something we will ever understand as a race? Because that is really, that's the golden question.
Yeah. I mean, it's the essential question, as you say. It makes us human. We believe it's consciousness. Now, there are some scientists, very many eminent ones, who say that everything has consciousness. The computer I'm talking to you on has consciousness, and the electrons within it have consciousness. I don't personally subscribe to that. I think it's pretty fanciful. But what gives me, sometimes when I'm depressed, when things sound too hard in my field of cosmology to understand, how the universe come from nothing, I look at my colleagues in the study of consciousness, and they almost have even less of an idea of how consciousness emerged. I'm not putting them down, but they sometimes can't even come up with a definition of what consciousness actually is. At least in my field, to give my colleagues our due, we have a very good definition of the alternative theories that lead to the origin of the universe that we observe.
Well, let me ask this, though. All living things supposedly have consciousness to a point, but consciousness is different in speed, I guess, within those living things. Like the consciousness of a tree would be very different than the speed of it would be very different than in a human being. So
yeah, I don't believe that all living things have consciousness. I don't think a cell has consciousness or a tree has consciousness. The actual studies in consciousness done by Stuart Hameroff at University of Arizona and his colleagues, are really done with objects whose consciousness you can turn off. He's an anesthesiologist. What he does is fascinating. He actually can turn off people's consciousness and examine, sort of the quantum origins of how consciousness could emerge. Now, his theories are very controversial, not widely accepted, but at least he's probing things. At least there's an on-off switch for that conscious behavior.
Well, but it also makes you question the point where if certain things like a tree does have consciousness and a human being does, the consciousness in a tree, which takes that much longer than to actually understand or figure things out, as a person does, it takes that much longer to die off than, I guess, as a human. So does that tie into other things, other areas when it comes down to the scientific study? If you think about it, with the amount of time something is actually, does that affect our span?
I want to ask: are you talking about lifespan as connection to consciousness?
That's kind of where I'm going with
Does a slower consciousness tend to mean a longer lifespan? Life. Yeah, I guess. Okay. Do you have an idea?
That, your notion that a tree has consciousness is one I would take issue with.
It has consciousness enough to understand that it has to reach out for things. It has to survive for survival.
Oh, well, that's life, right? So that's that's this kind of natural selection and evolution, et cetera. So that's different than consciousness. Consciousness is another great mystery, and it's separate from the origin of life, which you may be referring to. And it's a state of awareness and understanding the existence of oneself. And there are many different levels of consciousness. The hard problem of consciousness. These are all sorts of things that are in great dispute. But again, I take a simple-minded approach, ironically. I say it's obvious. Consciousness is like, what the Supreme Court used to say about pornography. It's obvious when you see it, but it's hard to define.
Let's change the discussion to something a little more contemporary, I suppose. You talk about the importance of science education for children, and especially for girls. And one of the things that I think has been a bit disappointing from our culture and maybe just nationally, and I don't know if this is true around the world, but it certainly seems to be true in America, is that there's far less interest in pursuing math and science and these very academic careers versus maybe 50 years ago when there was a space race, when we were looking to go to the moon for the first time. What are your thoughts on all that?
Yeah, somebody once said, the problem with basic science, which is what I do, is that sometimes it produces technology. In other words, that you almost expect there to be a benefit, like there was with the space race, which was a competition I compare in my book to the pursuit of the Nobel Prize. We want to get there first, and it really only matters who gets there first. Neil Armstrong was much more famous than even Buzz Aldrin, who followed him by 10 minutes or whatever. So I think this emphasis on conquering, conquest, et cetera, is endemic to human spirit, but it doesn't mean we can't rise above those tendencies as well. And so I think the pursuit of basic knowledge for its own sake is worth it, but it's really not as well supported as practical or applied research. And I think we live in the greatest country in the world for scientific research, so I'm not going to denigrate it. It's supported more than any other country. But the request, the demand to get better computers, faster cell phones, better battery life, those are all great, important technological things. But they don't really, relate to fundamental human curiosity. They're great challenges, good puzzles to work on, but they're not about the basic things that make human beings who we are, which is curiosity. And so I've taken upon myself, to really kind of educate my children in a way that appeals to their own unique, creative, individual identity. And I think we can do that as a species only when we ourselves are curious and when the teachers are curious and not jaded and not burned out and not worried about kind of the mundane, pedantic things that they are unfortunately forced to worry about in today's modern, society.
This is a little bit of an adjunct to what you just said. I live in a very small community, Cooperstown, New York, which has a rather large hospital for the area. So we're very dependent upon the medical community for our economy here. And one of the problems I continue to hear is that, particularly when it comes to American students, people are not entering the medical profession because they're not entering pursuits that involve science and math. Is that the same problem?
I think there's a relative problem. There's also political, economic forces at work. I'll say from the perspective of basic physics, we have a physics program at UC San Diego, which I think is second to none, and yet we have a substantial number of physics majors who didn't start off as physics majors. What do they start off as? Computer science majors, where they wanted to, develop the next hot app or website or Facebook social network, right? So, we're getting great students and they have great skills, but it's a little dismaying to see it as a second choice rather than kind of the first choice. It's often shown that, said that science is really founded on the trunk of a tree, and the trunk of the tree is physics, and everything grows out of physics, including biology, chemistry, et cetera. And the roots of the tree are really mathematics and logic and philosophy. And so I think we ignore the roots and the tree will fall. And unfortunately, I do see much more of an emphasis on that because there's economic reasons to go into computers and apps and social media.
Do you view the migration of our effort to reach space physically, to go to space, whether it's the moon or Mars or wherever, into the commercial sector versus the public sector, as a good thing for that effort and a good thing for science, or do you think it muddies the process?
I think, personally, I have a vested interest in us not doing that because, and so just being upfront about that, and the dollars used for manned space exploration usually come at the expense of basic science research, telescopes in space and robots in space. And I do think that we can do a lot more on Earth with human beings and a lot more in space with robots. And I have failed to see a lot of the applications. Andy Weir, who wrote The Martian, his latest book was Artemis. He's a UCSD, he went to UCSD, and I interviewed him about a year ago for my podcast, and he said things like, well, probably the best reason to go to space will be in the next 100 years will be tourism. And I think that's a horrible scientific reason. It's of course appeals to our notion of, conquering and exploration. I think that's fine. I want to be an astronaut. I am a pilot. But if it comes at the expense of basic research, of building telescopes and robots that could potentially go to another star system, just imagine that. Not in our lifetimes, maybe not in 1,000 lifetimes, but that we can be part of an intergalactic or, intragalactic spacefaring civilization is just too exciting to think about, even if it means that it might be an AI that does the exploration for us, not human beings.
You have a podcast, you've got a book, your website is briankeating.com. Tell the folks listening where they can find all of this and maybe listen to the podcast, et cetera.
Yeah, so I hesitate to fill up your spam mailboxes, but if your listeners go to my website and sign up for my mailing list, which is briankeating.com, you'll be asked to sign up. And the first 10 of your listeners that use hashtag Beyond Reality, I will send a piece of space dust to, so a meteorite to, because I really want to explore the passion that I have for science with your listeners. So the first 10 people in the U.S., and that includes Cooperstown, I'm a native New Yorker, so I love that area, all across the U.S., go to briankeating.com, sign up for my mailing list, and use the hashtag Beyond Reality, and I will send you a genuine piece of space dust.
Oh, wow. And you said the first 10 that do that?
Yeah, with
Terrific.
that hashtag Beyond Reality.
With the hashtag Beyond Reality. Well, Brian, thank you so much for being here. Fascinating conversation. Anytime we talk about this topic or topics like this, it's kind of a mind-blowing discussion. This was no exception.
The pleasure was all mine, guys. Good night.
I just want to get this clear. Did you really just compare me to a piece of dried ham? Is that what you just said?
Hang on. That you're just throwing that out there.
Well,
people don't understand the context.
I thought that's what you just said.
No, you're crazy. So you're crazy.
Okay. Well, you know what? I'm not crazy
it's
about.
It's in reference to some pictures. I don't even know how to say it now. I really don't.
I don't think we need
to
to
no matter
talk
what,
about
it's going to dig a hole deeper.
Yeah, we don't need to talk about it anymore. Brian Keating, by the way, I want to mention that his website, you got to be very careful if you're going to go there. Don't put the www in the web address. So just type briankeating.com. It's not that it's anything bad. It's just a different website if you add the W's. But if the first 10 people that go and sign up for his email list and add the hashtag Beyond Reality he'll mail to them a piece of space dust, which is kind of cool.
That really is kind of neat.
Yeah. I mean, not many people have that.
No, I mean, yeah, it's I don't even know where you get it, but
anyway. I guess you get it from space. I guess it comes down in meteorites. I mean, it has to show up that way. It's the only way, right?
Well, I would think so, yeah. But anyways, all right. So yeah, definitely a big shout out and a thank you to Brian for coming and hanging out with us tonight and just really getting deep into discussion. I think it was such an interesting topic. Tomorrow night we're talking with Sabrina Scott, witch, artist, and writer. And she'll be discussing what it's like to be a practicing witch. And she also has a degree in environmental studies, and she's pursuing a PhD. So make sure you check that out. And then Thursday, we've got Bill Phillips, author of Signs from the Other Side. So that's going to be a great show as well. If you haven't yet, head over to facebook.com/Beyond Reality Radio. Like that Facebook page for us. Then head to beyondrealityradio.com. You can find all the stations we are on across the country. That list is constantly being updated with new stations being added, so check it often. You can also download the free smartphone apps, which allow you to listen to the show live or catch the show on the go. You can listen to past episodes and everything else on it. So make sure you check that out. If you download the show or you subscribe on iTunes, take 2 seconds for your time and rate it for us. It helps push it forward and gets the word out. And that's what it's all about, just spreading the word. We greatly appreciate the support. That's going to pretty much do it for us tonight. You listen to Jason and JV, Beyond Reality Radio. Catch you all tomorrow.
Beyond Reality Radio is hosted by Jason Hawes and JV Johnson and produced by Alexandria Johnson and Slick Eddie Edwards for Entercom Radio. Beyond Reality Radio is distributed by Westwood One Radio Networks. Stop by our Facebook page and say hello. Follow the hosts on Facebook as well. For Jason Hawes, follow at jasonhawes.taps. For JV Johnson, follow at JVJ Paranormal. If you'd like to be a guest on Beyond Reality Radio or you have a suggestion for a guest, contact Slick Eddie Edwards at slickeddieedwards@gmail.com. Be sure to visit our chat room as well at beyondrealityradio.com. Thanks for listening.